Hi everybody, hi. Hope you guys are hanging in. Okay, so we're going to do the problems that were on CourseWeb. Hopefully you tried them. I don't know. Okay, so I'm going to write down our formulas. Oh man. Okay, just to kind of drive home a couple things. Periodic growth, okay, that's when it's compounded annually, monthly, weekly, daily, that kind of thing. The time is always years, always. Continuous, also known as exponential growth or decay, the time is whatever is given in the problem. It could be years, but it doesn't have to be. It could be hours, it could be minutes, it could be seconds, it could be decades, whatever. The last part is, if it involves percentages, like radioactive stuff or anything like that. It doesn't have to be a decay, but if it involves percentages, A sub naught does not matter. Okay, so let's take a look at number one. By the way, Tucker is my dog. He's apparently quite wealthy. So, $100,000 at 8.5%. And that's realistic. Okay, so for all of these, I want to know how long until he has $500,000. Okay, given the different situations. So the first one is annually. Okay, since the compounding is non-continuous or exponential, that means it's periodic. So in this case, the ending amount is $500,000 with an initial investment of $100,000. Then we have 1 plus, here's my APR, my annual percentage rate, written as a decimal, that's 0.085. And it's annual, so the N is a 1. I'm not going to bother writing that, okay, because that's annoying. Okay, and it's asking me how long. That tells me my variable is t, time. Okay, so the first thing that I want to do here is divide both sides by 100,000. So that gives me 5 is equal to 1.085 to the t power. Remember, solving for this funky thing, going to take the natural log of both sides. And I do that so I can bring this t out front. So the natural log of 5 is equal to t times the natural log of 1.085. So we divide both sides by the natural log, 0.085. Okay, now remember this is the natural log of 5 divided by the natural log of 1.085. It's not the natural log of 5 over this number. Okay, it's two logs. Okay, so t is equal to 19.7 years. Okay. Another clue for the years is you're given an annual percentage rate. A lot of times students have the tendency, like the next part of this is going to be the same thing, but N is going to be, it's going to be monthly. And so then you want to write your answers as months. Well, think. You're not going to grow from 100,000 to 500,000 in 19 months. If you are, I'm banking where you bank. Okay? All right, so now the only thing that's going to change to do monthly is instead of a 1 for my N, I have a 12. So, oops. Monthly. Okay, so ending amount 500,000. Initial amount, 100,000. 0.85 over 12 to the 12t. That's all. Okay, again, divide both sides by 100,000. So you're going to have 5 is equal to, let's see, 0.085 divided by 12 equals plus 1 equals 1.00708 to the 12t. Okay? So to go from here to here, I divided both sides by 100,000, just like in part A. Okay, have to get this out of here, natural log. So natural log of 5 equals the natural log of this junk. Bring your 12t down here. Luckily, before all this Armageddon stuff happened, we were able to do some of these problems. I find it easier to do this in 2 steps rather than 1. So I'm going to divide both sides by the natural log of 1.00708. Okay? So just rather than the 12 times it, it's easy to make a mistake when you do it that way. It's easy enough for me to make mistakes anyway. Okay, so natural log of 5 equals divided by natural log 0.00708 equals. We'll go over here. Okay, so 228.13, close enough, equals 12t. Okay, so that's approximately what that is. Divide both sides by 12. And I'm going to get t is equal to 19 years. Okay, not months. Compounding is monthly, but I'm using this. The time is always years. Ta-da! Okay, so part C, daily. Really? Okay, so there's 365.25 days in a year. Okay, so you have your 500,000. You can skip this step at this point because it's exactly the same for all of them. But 1 plus 0.085 over 365.25 to the 365.25 t. Divide both sides by 100,000. So you can have 5. And I'll go ahead and do this calculation. 0.085 divided by 365.25 plus 1. Okay? You're going to have to take it out decimals or it's just going to be 1 to whatever power is just 1, and that's not going to help you. So now I'll take the natural log of both sides. Okay, I do that so I can bring this value so my variable isn't in a funky position. Natural log of 5 equals 365.25 t. Natural log 1.00023. I'm going to do it in 2 steps again. Divide both sides by this natural log. You know, it's just simple algebra. I'm trying to isolate the t, so I got to get this stuff off of there. But alrighty, natural log of 5 divided by the natural log 1.00023. Ta-da! Okay, so 6 point. Whoa, that can't be right. Natural log of 5 equals divided by the natural log 1.00023. Really? Okay. Apparently it is right? Okay, so that's what you get. Now divide both sides by 365.25. I don't even know if that's showing up on the camera. Okay, and I get t is equal to 19.2 years. Okay? Alright, now, same problem, but if the compounding is continuous, we're going to use this, which is easier than this. It's less writing anyway. But all of this stuff, you know, when you're doing a problem like this, you wouldn't get, say, 19 years for one of them and 30 years for another, or 2 years for another. Okay, they should all be in pretty much a ballpark range, somewhere between, say, 18 and 20, or something like that. Okay, so this is continuous. Remember, that could also be called exponential. Okay, so, again, ending amount, we're looking for 500,000. Initial amount, 100,000. The K in this instance is 0.085, and then T is still my variable. Divide both sides by 100,000, so you can have 5 is equal to e to the 0.085 t. Get t out of that funky position, take the natural log. So that's natural log of 5 equals 0.085 t, natural log of e. What's the natural log of e? Good job, 1. Okay, so divide both sides by 0.085. I love this stuff. Okay. And for this one, I get t is equal to 18.9 years. Okay? The more frequent the compounding, the faster you'll reach that goal. Okay. All right, problem number 2. Let me look here a second. Okay, compounded weekly. Okay. So problem number 2. Jennifer saving for the down payment on a house. She wants to have $45,000 in 10 years. How much money should she stick away? Okay. So she wants, okay, the amount after 10 years, okay, A of T, she wants to be $45,000. That's the goal. Okay, APR, oops. Okay, our APR is 6.4%. Okay, and we're looking for A sub naught. And it is compounded weekly. I'll write that here. Okay, it's a weekly. Okay, so the ending amount, so it's periodic compounding since it's weekly, not continuous nor exponential. So here, the ending amount, 45,000. The beginning amount is what I'm trying to find. Okay, then I have 1 plus 0.064 divided by 52 because there's 52 weeks in a year. And then to the NT, so 52 times 10 years. I'm given the T in the problem. Okay, so we're going to do this calculation first. So I have 0.064 divided by 52 plus 1 to the 520th power. So you get $45,000 equals A sub naught times 1.896. Simply divide both sides by 1.896. So we have 45,000 divided by 1.896. So she needs to deposit this much. Don't forget your dollar sign, okay? Because we're looking for ace of knot is going to be an initial amount, so that's money. Money, money, money. I'm losing it, you guys. Okay. Okay, continuously, blah, blah, blah. Exponentially. Okay. All the rest of these are going to use this continuous formula. So I'm just going to write that one formula up here because that's all we need. A of t equals a sub naught e to the kt. Okay, remember K is the rate of either growth or decay for whichever time is given, hours, seconds, years, whatever it might be. Okay, so problem number 3, okay, these are all two-parters, the rest of these. Okay, so there's a nuclear power plant accident, contaminates the water. Okay, it takes 56 for the water to be safe to a level of 8%. What is its half-life? Okay, so the first part, 8%, 0.08. That's the ending amount. That's a percentage problem. For percentage problems, I don't need an a sub naught. Don't make these hard, they're super simple. Okay. It takes 56 weeks. I don't know what the rate of decay is for this radioactive stuff. Okay, that's what I'm trying to find. So just like with the others, I'm solving for this variable in a funky position, natural log. Okay, do that so you can bring your 56K out front. So the natural log of 0.08 equals 56K natural log of E. That's the whole point why we do natural log instead of common log. It's because this makes that one so easy. So just divide both sides by 56. Okay, so natural log of 0.08 divided by 56. Okay, so K is going to be negative 0.045. I expect this to be negative because I'm doing a decay, which is negative growth, anti-growth. Remember also when you take the natural log or any log of a value between 0 and 1, it's going to give you a negative answer. So don't let that throw you. Okay, so that's the first part. Now we have to answer the question, what is the half-life of this isotope? Half-life is how long it takes until there's 50% remaining, half. So the ending amount would be 0.5. It's a percentage problem. I don't need a sub naught. I have E. And half-life is the time it takes until there's half as much there. So I'm solving for T. So this is my decay rate, negative 0.045, and there's my T. Again, solving for this guy, natural log of both sides. Now, since this is a value between 0 and 1, it's going to give me a negative. And that's fine because I'm going to be dividing by a negative. Okay, so natural log of 0.5 equals negative 0.045 T, natural log of E, which is 1. So you're just going to divide by negative 0.045. Okay, so natural log of 0.5 divided by negative 0.045. And that's going to give me 15.4. Now, you go back to the problem and you say, what was my unit of time? Well, in the problem it told me it took 56 weeks until there was 8%. So this rate that I got here is a weekly rate. Okay, so it's decaying by this amount per week. So when I'm solving for this T, it's going to be weeks. Okay, so periodic compounding, always years. Continuous or exponential, whatever's given in the problem. Okie doke. Okay, we're going to make a timeline for this. Okay? Not to scale usually, but whatever. Okay. There are 40 rabbits on an island. Okay. 40 rabbits. This is at the beginning. All right. And after 3 months, there's 76. Okay. This is increasing exponentially, so this formula. How many at the end of 2 years from the beginning? So 2 years from beginning. That's what I'm trying to find. How many rabbits? Okay. Here I have 2 different units of time. I want to be consistent. So I'm either going to convert months to years or years to months. Doesn't matter which one you do, but you want to be uniform. If I convert to years, this is 3 months is a quarter of a year, so it'd be 0.25 years. If I convert to months, this would stay as 3 months and this would become 24 months. I'd rather do that than have a decimal. So I'm just going to do that. You can do it the other way if you want. You get the right answer either way. Okay, again, this is a 2-parter. I use this information to get me my growth rate, and then I apply that to answer the question. Okay, so we want to get K. So the ending amount, there's 76, starting with 40, growing exponentially for 3 months. Okay, so divide both sides by 40. So you have 1.9 equals e to the 3k. Getting pretty good at this whole natural log stuff now, huh? Isn't it cute? Okay, gotta get this guy out of the funky position. So natural log of 1.9 equals the natural log of e to the 3k. And I do that so I can bring the 3k out front. So the natural log of 1.9 equals 3k natural log of e, which is 1. So divide both sides by 3. And k is equal to 0.21. Close enough. Okay. So now that I get k, I can answer the question. How much am I going to have 2 years from the beginning? Okay, now, because this is months, this gives me a monthly rate. That's why we want to make sure that we're consistent. So for my time, I'm using 24 because I need to make sure they're jiving. Okay, so I want to know how much I'm going to have in 24 months from the beginning. The beginning I had 40 rabbits. My K is 0.21 and my T is 24. Okay, now, students get really confused with this. Remember, this is A of 24. That's not, there's nothing that I do with that. This is what I'm trying to find. The amount of rabbits after 24 months. This is the calculation, so it's just all in your calculator. So 0.21 times 24, then e to that power, times my initial amount of 40 rabbits. And it's going to give me 6179 rabbits. Okay? So that's not too hard. I don't think it's too hard. Okay. Excuse me. So I found out last night one of my cousins has coronavirus. She lives in Nashville. She's 49. But she's used to be a smoker, now a vapor. So as far as I know, she is not in the hospital, but she is really sick. So I hope all of you are well and everybody in your family is doing well. All right. This is insane. Okay, so number 5, going to make another timeline. So we have 4 years ago. 4 4 years ago, we have $470 in the bank. Now, your balance is $612. Okay, now this is, you didn't deposit or withdraw anything, and that's just what it is. Okay. After another 30 years. Another 30 years means 30 years from now. And I want to know how much money I'm going to have. So there's 4 years here, okay? And there's 30 years from now, so this is 26 years. Whole thing's going to be 30. Okay, two-parter. Use this stuff to get my growth rate and then apply it to answer the question. So ending amount is 612. Initial amount is 470. And it was 4 years times whatever that growth rate is. Divide by $470. So I get 1.3, good enough, equals e to the 4k. Natural log of both sides. That allows me to bring that 4k out front. ln v equals 1. Divide both sides by 4. Okay, that gives me, that's my k. All right, now to answer the question, 30 years from now, that means that's my a sub naught and my t is 30. You'd still get the right answer if you use this as a sub naught and you use your time as 26 years. But let's not confuse the issue. Let's just make it easy. So I'm looking for the amount after 30 years, starting with $470, growing at this rate for 30 years. Okay, so 0.066 times 30, then you take e to that power, and you multiply that by the 470. And you get 3,404. Okie doke. This just tells me the APR was 6.6%, compounded exponentially or continuously. Okay, so that's that one. All right. Okay. So again, I'm going to make a little timeline. Number of people live in a country about 2 years ago. All right, 2 years ago, we had 6 million. Okay. This is now, and it says in 10 years. So that in 10 years is 10 years from now. $11.75 million. This is kind of a dumb problem. I got this from your book. Anyway. Okay, so here we're going to use the given information, going from 6 million people to 11.75 million in a course of how many years? 12. Good job, guys. Right? There's 2. Here's another 10. So it's 12 years. So the ending amount is 11.75, starting with 6, and it's going 12 years times whatever that growth rate is. You just need to be careful. This timeline takes 2 seconds to make it, and then it makes it so much easier to get the problem right, I think. Okay, so 11.75 divided by 6, 1.96, close enough. E to the 12k. Natural log of both sides. Okay, that allows me to bring my 12k out front. Divide both sides by 12. I'm going to need more markers. All right, so I get K is equal to 0.056. Okay, so that gives me a yearly growth rate for that. Now to answer the question, okay, I want to know this. So A at 2 years, starting with 6 million people and growing at this rate for 2 years. And I get 6.71 million people. Remember units. Units count. All right. Almost done, you guys. It's a really gorgeous day. I gotta get outside before I lose my mind. Okay, number 7. Okay, medicine has a half-life of 12 hours. How long until there's 10%? What does that tell me right off the bat? That I don't need A sub naught, my initial amount. It doesn't make any difference in these percent problems. Okay, the given information, a two-parter, the given information, half-life of 12 hours. So this means there's half as much after 12 hours. I don't know what K is. I use that to answer the question. Okay, so I have to take the natural log of both sides. So that's the natural log of 0.5 equals 12K. Natural log of E, which is 1. Divide both sides by 12. Remember, taking the natural log of a value between 0 and 1 is going to be negative, which it should, because this is a decay problem. So natural log of 0.5 equals divided by 12. So K is equal to negative 0.058. All right. How long until 10% remains in the body? Okay, well that's 0.1 is 10%. Don't need the A sub naught. It's e to the negative 0.058 t. When it says how long, it's looking for t. Natural log of both sides. So natural log of 0.1, bring this value out front, 0.058 t. Natural log of E equals 1. Divide both sides by negative 0.058. And I get 39.7. Go back to your problem, and my unit of time is hours. Okay, so it takes 12 hours until there's half as much of the medicine in your bloodstream. You can expect it to take a whole lot longer until there's only 10% in your bloodstream. So that makes sense. Okay, number 8 is a similar kind of problem. Okay, 2% of an illegal drug is in the blood after 5 days. How long would it take until 25% is in the blood? Okay, so we have 2% is 0.02, not 0.2, that's 20%, okay? After 5 days, so e to the 5k. Natural log of both sides. That allows me to use that log property where I can bring that value out front and divide both sides by 5. So K is equal to negative 0.782. All right. How long until there's 25%? 0.25% problems don't need A sub naught. Okay, it says how long. That tells me that t is my variable. So the natural log of 0.25 equals the natural log of this stuff Forgot the E. Okay, that equals 1. Divide by that amount. Okay, go back to your problem, the unit of time, days. Okay, it takes 5 days to have 2%. It's going to take fewer days to have 25%. Okay, one more. Okay, colony of bacteria is growing over a period of time. How much in a week? Okay. After 1 week. Well, you know what? That's an ambiguous problem. Let's use 1 week from the beginning. Sorry about that. I hate when I do that ambiguous stuff. Okay, so I wasn't very specific. So pretend like there's another sentence on there, and it says how many bacteria will be in the colony after 1 week from the beginning. Okay, so it's a two-parter. So we're going from, we have an ending amount of 800 bacteria starting with 100 in 6 hours. Okay, so divide both sides by 100. So 8 equals e to the 6k, natural log. Divide both sides by 6. So natural log of 8 divided by 6. So k is 0.347, close enough, per hour. Okay, now, this is an hourly growth rate. I need to be consistent with my units of time. So I need to figure out how many hours in a week. Okay, well, there are, okay, I want to end up with hours per week. Okay, so I want to end up with hours per week. So I'm going to have, there are 7 days in 1 week times 1 day has 24 hours. I just realized I screwed up on another problem. I put 24 for 2 days or something, and it should have been 48. No, I did it right. It was years. Never mind. Don't pay any attention to me. Okay, so here days cancel, so I end up with hours per week. So I always let my units be my guide when I'm not sure, what am I supposed to do. But you don't actually have to do that. You can probably just figure it out. It's 168. So that's how many hours are in a week. So we're going 1 week from the beginning. So I'm looking for A at 168 hours, starting with 100 bacteria and 106, whoops, do where K. Where's K again? Okay, 0.347 times 168. Okay, remember, again, this is not a calculation. That's what we're trying to find by doing this stuff in your calculator. Okay, so 168 times 0.347 equals, take e to the power, multiply by 100 back. Aw, syntax error. Shenanigans. 0.347 times 168 equals EX times 100. That's a lots of bacteria. 2.08 times 10 to the 27th power. bacteria. You're going to need an antibiotic for that one. Okay. So, I have no clue how to test you guys on any of this, but what I sort of do. I'm going to put like 2 problems on CourseWeb. And I want you to, if you have a printer, that's great. You can print it out and take it and then either scan it and email it to me with your answers, or take a picture with your phone and email it to me with your answers. If you do take a picture, please make sure it's in focus, and please try and write neatly, because I'm going to have a lot of grading to do like that. I still have a whole grading to do. I can't focus. So I'm sure you guys can't either. I really miss you all so much. I look at my roster and I look at your names and I picture your class and where everybody sits, and I think of everybody's different story, and I think about the baseball players, and I think about, just all of you. Anyway, we'll get through it. Oh, I have a reason to wash my hands even though I haven't left the house. Well, except I went to Twin Lakes Park with my husband last night after supper, and it was horrible. People wouldn't even say hi. Like they looked shocked because I said hiya, even though they were more than 6 feet away from me. Anyway, it's the end of the world as we know it. I feel fine. I love you. Till next time.